Yes, I
PPT.
can see your presentation, but
So thank you,
make
thank
your
you.
presentation to the
Now,
presentation mode.
now I am starting to deliver my
Yes.
lecture on the topic of investigation of alpha radioactivity levels in commonly used organic and inorganic fertilizers by using Ca-39 SS entities, that is solid state nuclear track detectors. This is my contents of my lecture: introduction, materials and method, results and execution, conclusions and references. Now, this is the slide for introduction. Now, fertilizers are commonly used for reclaiming or improving the soil fertility in agricultural lands and to enhance the yield of plant products such as crops, fruits, vegetables by supporting nutrients reserves in the soil of the agricultural lands. The fertilizers consist of many essential micronutrients and macronutrients which are all helpful to support the plant's growth and to increase the plant's products. So, fertilization in agricultural activities is one of the most important ways for increasing the efficiency of plants' nutrients in soils and obtaining a better quality of plants' products. So, categorically, fertilizers are of two types: organic fertilizers, which is also known as organic manures, and other is inorganic fertilizers, which is also known as chemical fertilizers. The organic fertilizers are usually are mostly produced in farmers' home or in farms, and some type of organic fertilizers are also produced in the fertilizer industries or factories. So most common raw materials used for production of organic fertilizers are different types of natural and environmental materials such as grass, plant leaves, food scraps, green moss, plant and crop residues, waste materials from homes, treated sewage sludge, guano, earthworms, animal excreta, human excreta, and animal bones, as well as some companies also used some powdered minerals. Examples of organic fertilizers, these are well known to us. For example, farmyard manure, green manure, compost manure. On the other hand, inorganic fertilizers are produced by using different types of rocks or minerals and chemical compounds. For example, phosphate rocks, potassium rocks, and compounds are used generally for production of inorganic fertilizers. These are the examples of inorganic fertilizers. Okay. Now, it is observed that the use of various types of inorganic fertilizers in the agricultural fields is a very common practice nowadays rather than the organic fertilizers in the conventional agriculture worldwide. Most commonly, the nitrogen, phosphorus, and potash based inorganic fertilizers are preferentially used by farmers in agricultural fields because plants' growth depends mainly on these three essential elements: nitrogen, phosphorus, and potassium. It is surprising see that apart from the essential plant nutrients provided by using the inorganic fertilizers in agricultural lands, it is observed that long-term application of the inorganic fertilizers results in some negative effects on the agricultural soils, agricultural lands, and also on the surrounding environments of the agricultural lands, as well as on human health through the food chain. One of which is the enhancement level of radioactivity, because the activity concentrations of natural radionuclides in the fertilizers, particularly inorganic fertilizers, are practically higher than the average of their activity concentration in the earth crust. Fertilizers are also included among the naturally occurring radioactive materials. The naturally radioactive materials contain relatively higher concentration of different types of natural radionuclides of uranium-238, thorium-232, and uranium-235 decay series. And their radioactivity is higher than the activity in our natural environmental materials like soils, water. The radioactivity of inorganic fertilizers is connected to the activity concentration of radionuclides and raw materials used for manufacturing the inorganic fertilizers.
The voice is not clear.
And IAEA have reported that ANSIAR and IAEA have reported that the phosphate fertilizers contain high concentration of naturally occurring radionuclides, especially of the radionuclide of uranium-238 TK series. Beside the presence of radioactive elements in the inorganic fertilizers, a significant amount of toxic elements such as some rare earth elements, fluorine, and some heavy elements in association with unstable toxic elements such as radioactive elements or radionuclides of the primary natural decay series of uranium-238, uranium-235, and thorium-232 are also present in the inorganic fertilizers, mainly in the inorganic phosphate fertilizers. These are reported some studies. These are reference.
Ωραία, το έχω αφήσει και παίζει. Απλά.
It is also observed that the inorganic fertilizers is said to reduce the antioxidant levels, and it has applying inorganic fertilizers in excess of plant nutrients can increase the chances of fertilizer loss and environmental pollution. For the above mentioned negative effects induced by the application of inorganic fertilizers on environment and human health, the application of organic fertilizers has been increased nowadays in agricultural sectors. Organic fertilizers have sufficient nutrient availability for plants, and their long-term application may not result in inducing such negative effects on soils, plants, and elements. Rather, their application led to induce beneficial effects on soil reclamation and yield of plant products. However, the organic fertilizers contain natural chemical elements that enhances the fertility of soil and water retention and improving the soil structure as well as help to grow the plants vigorously and productively. Therefore, the use of organic fertilizers sustain the soil quality. The organic fertilizers have been proven to enhance the antioxidant content in plants, whereas the inorganic fertilizers reduce the antioxidant level in the soil and hence plants. Apart from the improving physical and biological properties of soil, the organic manures help in improving the efficiency of chemical fertilizers. It is very studied that the organic manures such as farmyard, poultry manure are known to improve the physical, chemical, and biological conditions of soil and ensure sustainable soil health. For such various beneficial effects of organic fertilizers, many farmers are interested to use the organic fertilizers largely, along with the minimum use of inorganic fertilizers in the agricultural sectors. Actually, organic fertilizers are derived from the materials. The radioactivity of these fertilizers are equivalent to the radioactivity of our earth crust. Because of the increasing practices of both organic and inorganic fertilizers in the agriculture fields worldwide, it is interesting to investigate the radioactive level in these fields. So, among the radionuclides present in our environment, the alpha particle emitting radionuclides have the ability to induce many health hazardous problems, which are malignant, either malignant and or non-malignant or both in the human body. Now, in the present work, the alpha radioactive level in some organic and inorganic fertilizers has been studied by using the CR39 solid state nucleotide detectors. These detectors is a alpha sensitive detectors. This can be used in our experiment for detection of alpha radiations that are emitted during the decay processes of radionuclides in the sample. For such measurement, the calibration factor for these detectors should be evaluated. For evaluating the calibration factor for CR39 SS entities, I have used a radioactive source material IAEA 448 soil, which is a radium-226 This is mainly at radium-226 source, and it is very well known. Radium-226 is a good alpha emitter, 100% alpha emitter. In evaluating the calibration factor, I have also considered the self-population of alpha particles within this reference sample. Now, this is the slide for the materials and methods. All the samples were collected from the local markets of our state, West Bengal, in India. Firstly, collected samples were fully dried by using oven and then crushed into fine powder by using mortar and pestle and then sieved. This is the container. This is the container, PVC container. This is the desiccator. Inside this is a field box where a sample of fertilizers were kept. And the sample of fertilizers were spread as a very thin layer at the inside bottom surface of this field box of dimension 1.0 centimeter height and diameter 0.5 centimeter. After spraying the sample this portion, a glass slide was put on this on the top of the field box and then well sealed. Whole experiment was kept in this desiccator for about 60 days. This during the period of the 60 days, the alpha particles that would be emitted from the sample material can be detected by the CR39 SNDT, because CR39 SNDT is a good alpha detector. After exposure period, the exposed CR39 SNDTs were aged using a chemically aged using a 6N NaOH solution at 70 centigrade in an etching bath for 6 hours. After chemically aged process, after completing the chemical aged process, number of tracks that revealed on this detector CR39 can be counted by an optical microscope provided with image analysis system. The background count of alpha tracks was also estimated by using a few unexposed CR39 SSMTDs. The estimated background count was then subtracted from the measured alpha track density to get the effective number of alpha tracks. Now, in order to estimate the alpha radioactivity of the samples, the detector was calibrated by reading it to a known radioactive source. That has been, I said earlier, using the source material, reference source material IAEA 448 soil, which is the radium-226 source. Exposure were continued for 2 to 3 days. And this gives a linear picture.
Voice, please. We can. The voice is lost.
From this is yes.
The voice, please. Lost.
Curve is showing the variation to the following. It may be signal. I am trying. The linear feet of this curve is showing the variation is according to the following equation: calibration factor equal to 0.10126 plus 0.02781 into sample mass. So for this sample mass, vector value. This equation is the alpha radioactivity measurement equation for the measurement of alpha radioactivity. Rho is the track density that is registered on the CR39 detectors. C is the calibration factor. M is the mass of the sample in milligram. T is the exposure time. And hold this factor can be expressed in unit of becquerel per kg. So 10 to the 6 factor is multiplied with this factor. This is table showing the calibration vector in unit of becquerel per tracks per square per minute, evaluated from IAEA soil, and also a column. This column showing the calibration factor value that were obtained from this graph. Also from this equation 1. It is observed that the theoretical value and the experimental value are well consistent with few exceptions. It is evident from table 1 and figure 2 that the sample masses in between 1.0 mg and 5.0 mg can be used for alpha radioactivity measurement in a solid and powder form material to avoid self-absorption effect. This is a part of my self-absorption study experiment, but I have observed that after sampling masses of 12 milligram, the self-absorption of alpha particles within this material will be very high and rapidly changes with increasing the sample mass after 12 milligram. Now, table 2 showing the data for alpha radioactivity of different organic and inorganic fertilizers. This table is for this part for the organic fertilizers, this part for inorganic non-phosphatic fertilizers, that is fertilizers, inorganic fertilizers which having no phosphorus material. This is inorganic phosphorus-based fertilizers. Organic fertilizers, in case of organic fertilizers, the minimum radioactivity found to be 29.55 becquerel per kg and maximum found 116.19 becquerel per kg. In case of inorganic non-phosphorus-based fertilizers, minimum activity found to be 2.26 becquerel per kg and maximum 10.71 becquerel per kg. But inorganic phosphorus-based fertilizers, we have relatively higher activity. Minimum found to be 495.42 becquerel per kg and maximum found to 1148.62 becquerel per kg. It is observed that minimum value of the alpha radioactivity is found highly for phosphatic fertilizers, then organic and non-phosphatic, and maximum found highly for phosphatic fertilizers, then organic and phosphatic fertilizers. And the range is given here. The alpha radioactivity of organic and non-phosphatic fertilizers is nearly equivalent or similar to those observed normally in environmental materials such as soil. But on the other hand, the alpha radioactivity of the inorganic phosphatic fertilizers is relatively higher than the alpha radioactivity of both organic and non-phosphatic fertilizers, because activity concentrations of alpha emitting radionuclides in the raw materials that are used for inorganic fertilizers production, particularly in production for inorganic phosphate fertilizers, are naturally much higher than the alpha emitting radionuclides present in the raw materials used for the organic and non-phosphatic fertilizers productions. Results indicate that the extensive use of phosphatic fertilizers can significantly enhance the radioactivity contamination level in the agricultural plants products and also on the surrounding environment of the agricultural fields. This is because of the redistribution of the radionuclides that are present in high level in the phosphate ores during the production process. Minimum alpha radioactivity found in non-phosphatic fertilizers and maximum found in phosphatic fertilizers This indicates that the non-phosphatic fertilizers are radiologically safe rather than the organic fertilizers. But it is very well known to us that the inorganic fertilizers, including non-phosphatic fertilizers, contain significant amounts of some toxic and stable elements and also contain fluorine. All these elements can enhance the contamination level in environments and can also use some health hazards problems to the consumers of agricultural food products. But the organic fertilizers are not containing such types of elements. This study suggests to increase the use of organic fertilizers in agricultural sectors. Further, the present study prompts the need for radiological assessment of communities. Those are living in cultivated areas where the inorganic fertilizers are used extensively, because radionuclides mix with the groundwater through soil, and people in cultivated area use that water for drinking and domestic purposes. Therefore, groundwater in cultivated areas also needs radiological assessment. However, the calibration factors, evaluation technique and experimental method described in the present study may be applied in the alpha radioactivity measurements in other solid and powdered form materials, including environmental and biological materials. Sorry. The novelty of the present research work relies on the calibration factor evaluation technique, because we are studying the cell evolution effect of alpha particles within the sample material. For Ca39 SNTTs, and the radioactivity data that are given can be useful as a good baseline for alpha radiation exposure to fertilizers. Now lastly, conclusions. A TRACS method using Ca39 solid-state nucleotide detectors has been used in the present study to measure the alpha radioactivity level in some organic and inorganic fertilizers. The calibration factor for Ca39 SSNTTs has been evaluated by using a distributed reference source material of IAEA 448 soil, which is mainly a 226 radium source. A variation of calibration factor with sample mass is showing a straight line. Equation obtained from the linear feet of this variation has been used to evaluate the calibration factor for a particular sample mass. The estimated calibration factor from this equation is used in the present study for measuring the alpha radioactivity level in the fertilizer sample. The measured values of alpha radioactivity indicate that the alpha radioactivity of inorganic phosphatic fertilizers is relatively high rather than both organic fertilizers and inorganic non-phosphatic fertilizers. Among the fertilizers investigated in the present study, the relatively low radioactivity has been seen in all inorganic non-phosphatic fertilizers. Phosphate-based fertilizers show the higher radioactivity among the inorganic fertilizers as well as organic fertilizers. Results indicate the extensive use of phosphatic fertilizers can significantly enhance the radioactivity contamination levels in the agricultural plant products and also the surrounding environments of agricultural fields. The present study suggests to increase the use of organic fertilizers in agricultural sectors to avoid exposure to radionuclides and some contaminants in presence in inorganic fertilizers. The novelty of the present study is the evaluated new calibration factor, or the process for evaluating the calibration factor for Ca39 track detectors using IAEA 448 soil for determining the alpha contamination level in terms of alpha radioactivity. The evaluated calibration factor for Ca39 SNTTs and the experimental method may be used reliably for alpha radioactivity measurements in other solid and powder form materials, including environmental and biological materials, in where the radionuclides are present. These are references. Thanks to all for attention.